higher degree polynomials. Something all squared minus that same something minus a number equals 0. Well, this looks a lot like a quadratic equation, where all of the stuff in the parentheses would be considered your variable. So what I want to do is let u equal all that stuff in the parentheses, x squared plus 4x. So if I do that, I would end up with u squared minus u minus 20 equals 0. Does that make sense? We took all of this and replaced it with u. Okay, so now we have a quadratic equation. This one can be factored. We have our u's. Factors of negative 20 that add up to a negative 1 would be a positive 4 and a negative 5. So if you set each of those equal to 0, you would end up with u is equal to a negative 4 or u is equal to a positive 5. But we don't want u, we want x. So what we need to do is resubstitute. Since u is equal to these two and u is equal to that, then we set them equal to each other. X squared plus 4x is equal to negative 4, or x squared plus 4x is equal to 5. Now we have two more quadratic equations. We need those to be equal to 0, so let's move those constants over. If you factor each of those, you would end up with x plus 2 is equal to 0. Here you would end up with, you're going to need a 1 and a 5, and the 5 is going to be positive. Then you need to set each one of these factors equal to 0. So you'll have x plus 2 equals 0, which means x equals negative 2. You would have x minus 1 equals 0, so x equals 1. Then you would have x plus 5 equals 0, which means x equals negative 5. So you actually have 3 solutions for this equation. You should definitely go back and plug them all into the original equation and make sure it's equal to 0. I did check this one already, and they are equal to 0. Look at the numerators of these fractions. It goes 2, and then 1, and then 0. That's exactly what quadratic equations do. They go 2, and then 1, and then 0. That's what the exponents do. So what I want to do on this one is let u equal x to the 1/5 power. If I do that, I will have u squared plus 3u plus 2 equals 0. Remember, if you put this x to the 1/5 right here, you would have x to the 1/5 squared, which is x to the 2/5. So that's how we come up with this equation. We're going to factor this since it's quadratic. We'll have a u plus 1 and a u plus 2. Set each of those equal to 0. And solve, and you get u is equal to negative 1 and negative 2. Now we don't want u, remember, we want x, so we'll take this and resubstitute it. So x to the 1/5 is equal to negative 1, or x to the 1/5 is equal to negative 2. Okay, to get rid of this 1/5, what we need to do is multiply, or raise rather, each side of the equation to the 5th power. Okay, so if we do that, we'll end up with x equals negative 1 to the 5th power is still negative 1. We'll do the same thing on the other side. Raise both sides to the 5th power. So you'll find out that x is equal to, because that goes away, negative 2 to the 5th power is negative 32. If you check both of those values, they do both work also. So for this particular equation, we need to make sure that it's equal to 0. So we'll move the 25 over, and we get this equation. Now this is a difference of squares. So what we want to do is factor it. We'll have x squared plus 5 and x squared minus 5. Set each of those factors equal to 0. Move the 5 over, so you end up with x squared is negative 5. Now whenever you square root both sides, don't forget you need to take the plus or minus of the right hand side. So x is equal to plus or minus. The square root of a negative is imaginary, and the square root of 5 we don't know, so we'll just leave it as the square root of 5. On the second one, move the 5 over, and you get x squared equals 5. Take the square root of both sides, and don't forget plus or minus. So x is equal to a plus or minus square root of 5. All four of those solutions do satisfy that equation. Okay, have a look at B. We can set this up in two separate pieces and factor by grouping. In the first two, we can factor out a y squared, and we'll be left with a y plus 2. And in the last two, we can factor out a negative 9, and we'll also be left with the y plus 2. Now in these two, we have a y plus 2 in common, so we can factor that out. We're left with a y squared minus 9. Now this part is difference of squares. So we have y plus 2, factor the difference of squares, so you get y plus 3, y minus 3. Now we set each factor equal to 0. And we solve them. If you move that 2 over, you get a negative 2. Move this 3 over, you get a negative 3. Move this 3 over, and you get a positive 3. These three solutions do satisfy that equation. Alright, so what we have here would be difference of cubes. And when you factor difference of cubes, remember you have small parentheses and large parentheses. So what do you cube to get 27t cubed? You cube 3t. And what do you cube to get 64? You cube 4. Since that's a minus, we're going to put a minus here. That means this sign is going to be a plus because it's always opposite this one, and the last one is always a plus. Okay, now you square the 3t, you square the 4, and in the middle you multiply 3t times 4. Okay, now you set each of those factors equal to 0. Okay, this one you can move the 4 over and divide by 3. So t is equal to 4/3. Okay, over here, this one actually won't factor, so we're going to need to use the quadratic formula. So t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This will simplify into negative 12 plus or minus the square root of negative 432 all over 18. When you simplify the negative square root of 432, you do get an imaginary number. So negative 12 plus or minus, that will simplify into 12i square root of 3 all over 18. Okay, if you need to review that one, go back to look at videos on radicals. Okay, that's how we simplified this part. Well, if you notice, the 12, and the 18 all have a 6 in common. So what I want to do is factor out a 6. That'll leave me with negative 2 plus or minus 2i square root of 3 all over 18. And then 6 will go into 18 3 times. So you're left with negative 2 plus or minus 2i square root of 3 all over 3. I did go back and check both of these solutions and this solution, and they do all three satisfy that equation. We have something might look like a quadratic, but I'm not quite sure. I think what we should try first is to see if we can make this one just a constant. That means we need to factor out an x to the 1/2 power. Okay, this is where you have to think a little bit. If you factor an x to the 1/2 out of an x to the 5/2, what are you going to be left with? I'll go ahead and write it, then we'll talk about it. Remember, when you multiply like bases, you add the exponents. So 1/2 plus 4/2 is equal to 5/2. So that part's correct. Okay. What about when you factor a 1/2 out of a 3/2? This 1/2 plus this 2/2 would give us this 3/2, right? And then for the last term, we just have a 28. Okay, well 4/2 is 2 and 2/2 is 1. So you have x to the 1/2 times x squared plus 3x minus 28 equals 0. Now from here you can factor what's inside the parentheses. So you're going to factor that into your x and your 4 and your 7, where the 7 is positive. Okay, set each one equal to 0. So x to the 1/2 equals 0. X minus 4 equals 0. X plus 7 equals 0. Well, the square root of x equals 0. If you square both sides, you just get 0. So x equals 0. If you add 4 to both sides, x equals 4. And if you add 7 to both, subtract 7 from both sides, you get a negative 7. Now on this particular equation, if you go back and check them, the negative 7 does not work. So this is not one of the solutions. It's an extraneous solution. So your solutions are 0 and 4. Okay, finally let's look at letter B. For this one, I think maybe we should try to make this equal to 1. So what we want to do is factor out an x minus 3 to the negative 2/3 power. Okay, so what happens when we do that? If you factor a negative 2/3 out of a positive 1/3, well, let's see what happens. Isn't negative 2/3 plus 3/3 equal to 1/3? It is, right? Well, if you factor it out of itself, you just have 1. Okay, so let's simplify that. X minus 3 to the negative 2/3 times, well, 3 over 3 is 1, and x minus 3 to the first power is x minus 3. So we're going to have x minus 3 to the negative 2/3 times x minus 4 equals 0. Set each of those equal to 0. Remember what this means though. You have to flip it over, so you'll have 1 over 2/3 as a power means the cube root of something squared. So the cube root of x minus 3 all squared. That's equal to 0, and also x minus 4 equals 0. Well, over here, when you try to solve this one, wouldn't you multiply both sides by the common denominator, which is all this stuff? Well, when you multiply 0 times all that, you just get 0. So you have 1 equals 0, and that's not true, is it? So this one gives us nothing. Okay? Over here, you add 4 to both sides, and you find out that x equals 4. That will be the only solution to that particular equation.